before class. We're going to go ahead and talk about, well, there's some due dates coming up. The annuities and amortization part 2 homework, that's due tonight. That's the stuff we talked about last time in class. So please make sure you do that assignment. And the workbook assignments are both due Friday, both workbook 1 and 2. If you don't remember which ones I assigned, the announcement I sent out last Friday through Moodle does detail what these problems are. And so mainly what I want to talk about is the Unit 1 assessment. So today's class period is us reviewing the Unit 1 assessment. And so the first tidbit of information about it, so as I mentioned last time in class, fairly briefly at that point, you can take this Unit 1 assessment anytime from 7 a.m. on Friday all the way to February 9th at 5 p.m. So 5 p.m. is the latest time you can start the test. And so, yeah, the 9th is Tuesday. So you have from Friday until Tuesday. And the Unit 1 assessment, it's basically a test you take on your own. There's no proctoring of any kind. I'm not going to hover over you. You don't have to use ProctorU. You don't have to use Respondus, Lockdown, anything. You just take it on your own. Use whatever resources you want to. No one's going to monitor you. You don't have to turn in any scratch work to me. You just take the test, and whatever you get is what you get. So there's no partial credit for it either. There's partial credit for the midterm and the final, but not for this test. So that's why you have to be careful about the answers you input when you take the test. And just to make sure there's no confusion, the test, the Unit 1 assessment will appear, it's going to pop up on the 5th. It'll be right under practice problems here. So it's not here yet. It'll pop up when it's available. And there's also a practice test. We're going to go over the practice test today in class as a review so I can tell you all about strategies for going about these problems. You don't have to take the practice test on your own. It's optional. When before COVID, it used to be a case where if you got a certain grade on the practice test, you'd get a certain boost to your grade, a small boost to your grade. That's not true post-COVID rules or the syllabus. So the practice test is just for your benefit. You don't have to take it. I'm not going to penalize you, but it's not going to help you in terms of grades, except for it will help you. It will help only in the sense that it'll make you more aware of what type of problems you to perhaps expect on the assessment. Additionally, there's 70 minutes. You have 70 minutes. You take it all in one sitting. So you just take it all in one sitting. If you get booted out, I think it tells you to contact me, but shouldn't have. Just make sure you have reliable internet connection. And it says it will appear in my math lab at 7 a.m. on February 5th, which is Friday. So that's sort of the details about the assessment itself. I believe the assessment counts as 6% of your grade. So the Unit 1 assessment is about 6% of your grade. So it has some weight to it. But does anyone have any other questions about the structure of the course, or not the course, the Unit 1 assessment before I go any further? And if not, you could just ask me after class or something. Besides for that, let's go ahead and open up the practice test. And I'll talk about different strategies for doing these problems. Okay, so the difference between what we've been doing before and what we're doing now is now all the problems are sort of mixed together. And with that, there comes a sense of, well, which formula do I use in what circumstance? So now it's not sections that are divided into themes that tell us immediately what to do. Now you have to read context and figure out which formula to use. I mean, on the Unit 1 assessment, you'll have all the formulas in front of you. And so now it's up to you to figure out which one to use and how to use it. So for this one, you pay $71 to a loan company for the use of $1,184. This is over the course of 96 days. What annual rate of interest did they charge? So as we go through all of these problems, we need to think about in our minds, well, there was 4 sections we went over. Which one of these 4 sections does this problem seem to correspond with? And so the section in particular doesn't mention anything about annual or monthly deposits. I don't really see anything like that.
Simple interest?
This is going to be simple interest. Yeah, this is going to be simple interest. They don't say compound anywhere. They don't say deposit anywhere. It's simple interest. It has to be simple interest. So when you break it down to simple interest, then there's one of 2 formulas that could be at play here. I is equal to PRT, or A is equal to P1 plus RT. And so it's really up to you to decide which one of these 2 formulas we use. So it seems like, well, you're paying $71 to borrow $1,184. So with that context alone, because both of these formulas have an R and a T, which formula do you think we should use here?
I equals PRT.
Yeah, we're going to use the PRT one. The reason why, the $71, that's a fee. This is a fee. Whenever you see the word fee, interest. I mentioned that in one of the first class periods. This is interest. So using this one, so I is equal to PRT. Also, another indication of this, the fee is normally a much smaller amount than the principal value. So normally those amounts will differ heavily in magnitude. But since we know the formula to use now, we now know the variables we should look for. There's an I, there's a P, there's an R, and there's a T. So I already said that the fee is the $71, which makes the principal amount $1,184. And they do have us borrowing for 96 days. So you would put 96 for time. Don't forget, you have to convert that to years. So it's 96 days, but how many days are in a year? They have us assume 360 days in a year. That's how much we divide by. We can go ahead and figure out that decimal value. Okay, so someone have their hand raised in the virtual side. For divide for the, let me go back here. I divided for the time because for the 96 days, we have to convert that to years. And to convert days to years, you have to divide by the number of days in a year. So that's why we divided. Again, that was roughly, in fact, I'll just make a little bit more space down here and go from there. That was 0.2666667 or something like that. Again, the more decimal places you use, the more accurate your final answer will be. So I'm just going to use all of them to be safe. You can use 6 or 7. And so R, the rate, is the unknown value. So if anything, we know what to plug in. 184 times the rate times 0.2666667. So the bad news is, since we're solving for R, and R is not by itself, we have to use algebra. But we can simplify the algebraic process by bringing together any numbers that are already next to each other. So these two numbers, we can multiply those together immediately. And the way to do that in the calculator, without having to write out the 0.26667, 1184 times second, and then the ANS that I was talking about. Or you can just type out all the digits, it doesn't matter. And you should get a number that looks fairly similar to this. Times R. And then from here, so by simplifying any terms we can put together in the beginning, now the algebra is pretty simple, what we have to do. We just divide both sides by 315.7 and all those threes. And the same thing goes here. So the rate is now 71 divided by that number. And then whatever this comes out to be, that will be the decimal form. So we can do that pretty concisely in the calculator as 71 divided by second and answer. So we don't have to type out everything. So they give us 0.22487333108. They give us that for R. There's only one problem with this though. The rate is expressed as a percentage. This number gives us the answer as a decimal. So we have to move the decimal place over 2 times to the right. Or, in other words, multiply that number by 100. So to go from the decimal form to the percentage form. So the final answer is 22. They say round to 3 decimal places, so 487. That will be the final answer. .487. So 22.487%. That would be the interest rate for this problem. Does anyone have any questions about this one before we move on? If not, then let's go ahead and move on to the next problem. So there's an annual interest rate on a credit card for 13.99%. If the minimum payment of $20 is made each month, how many months will it take to pay off an unpaid balance of $115.19? So the first question is, all right, we have 4 sections worth of material. What section does this fall under, it seems like? So there's an interest rate. So every section has an interest rate. Minimum payment of $20 is made each month. What's that? It's that TVM solver thing. As soon as you see payment each month, that's an immediate indication this is the TVM solver. And as soon as you can figure out which one's which, then that tells you that there's a whole bunch of different values to solve for. So we go back to the 7 values for the TVM solver we talked about really in the last 2 class periods. So now we need to figure out which values go where. And besides for the obvious one of 13.99%, does anyone happen to see any other ones?
Is PMT -1?
Yeah, PMT is -20. I mean, that's the whole reason why we use the TVM solver in the first place. It's because of this addition of a new variable, which is PMT. So let's see, we have the interest rate. And yeah, we have the interest rate. And Kanisha, did you have a question? Is the PV, oh, okay, let's see. So you're definitely right about the PV. The PV is $915.19 because this is the amount of debt we're starting off with from the credit card. That's the amount of money we borrowed, and now we have to pay that off over time, which immediately means the future value is 0. We hope to have 0 debt in the future. And since everything's talking about months, each month, how many months, we can go ahead and put 12 and 12 for the last 2. And then that means for capital N, that's what we're solving for. They want to know how many months it will take to pay this off at this rate. So the bad news about TVM solvers is, well, there's a lot of variables, but the good news is you have to do really no work after you select everything. So some people like it more, some people don't. Let's go ahead and put everything in. Now that we plugged everything in, the value we are looking for is capital N. So remember, alpha, enter. The problem tells us, oops. The problem tells us that N is, notice what it wants us to do. Round up to the nearest integer as needed. So they want us to round up. So instead of 65.78, I'm going to put this, actually in red, I will put 66. Round up to the nearest integer, nearest whole number, in other words. So round up to 66. And so that would be the answer. Again, if on your assessment, if you put 65 point, whatever it said, 75, I can't remember. and it marks you wrong and you email me, hey, I was close, I didn't round right, can you give me partial credit? I cannot, unfortunately. So, again, that's not my rule, but I cannot give partial credit. So please make sure you make sure to follow the formatting. If it's the midterm and that happens, I will gladly give you almost all your points back. Because that's, you pretty much did everything right. That's why I emphasize, please watch out for these minute little details here. They sneak up on you and they get me sometimes. Does anyone have any questions before we move on? If not, let's keep going. Okay. A person makes annual payments of $1,000 into an ordinary annuity, 5 years. There's a little over $5,000 in there. $5,700, 46 cents. What annual nominal compounding rate has this annuity earned? So, all right, let's go back to the thought process. Anything? What section or what formula do we deal with in this problem? So if let's say it were compound interest, what compounding period would it be? What's that? You would think any talk of, where is it at? Annual payments of $1,000. So it's a TVM solver. So even though it has the word compounding there, it's misleading on purpose, because there's a lot of TVM problems that say compounded annually, compounded monthly. But as soon as you see periodic payments, that immediately tells you you have to use the TVM solver. That immediately tells you that. So we're back to the TVM solver. Which means we go through all of the different values again. EV, and there's PMT, FB, P over Y, C over Y. And so the motivation for using the TVM solver was exactly the $1,000 annual payment. That immediately tells us that PMT is negative 1,000. Remember, PMT is always negative. From here, well, the word, oh, you have one?
Do you have to put the negative in the calculator, or just automatically assume what the payment is going to be?
You always want to put the negative for the PMT in the calculator. I suppose that's us telling the calculator, explaining to the calculator the direction of the transfer of money. So that the negative is saying, I'm giving that money up. And the calculator is thinking, oh, okay, cool. Well, I'll count for that. Because there's some situations in more advanced scopes where PMT could be positive, where the transfer of money is all going in the same direction, but we don't deal with that in this class. So you always want to put negative for PMT every time, no matter what. And so, see the word annual pop up a lot. So annual is going to tell us how many times we're paying a year, 1 and 1, and compounding a year, 1. And that's because I'm seeing all these mentions of annual here. There's another annual right there, which means we can build up actually, we can get capital N, 5 years, compounding annually. Really, capital N is 5 times 1, which is of course 5. So you can put 5 times 1 or 5, doesn't matter. Does anyone see any other?
Would FV be 5,740?
FV is, in fact, what you said. 46, which automatically makes PV 0. One of those always has to be 0. And so we filled in everything else. So I guess the interest rate is what we need to figure out. So with all of that established, go straight into the TDM solver. I for N, placeholder 0 for I, 0 for PV, negative 1,000 for PMT, 5700.46, 1 and 1. The interest rate comes out to be and we want to round to 2 decimal places. We want to round to 2 decimal places. .56. 6.56, which is exactly what we can type here. 6.56. Again, if you put 6.55 and forget to round up, my math lab will count the whole problem wrong. It's very unfortunate. I agree, but again, just please make sure you're careful with those formatting things. You can do the whole problem right and just have it all swept underneath you because of rounding or formatting. Does anyone have any questions before I move on? All right, let's move on. So there's a $90,000 house. It costs, how much will this house cost 7 years from now? If the price appreciation averages 8% compounded annually. First question, which formula or method do we use? This is compound interest. So this is where we use compound interest. There's no periodic payments whatsoever. There's nothing about paying annually, paying monthly. This is just compounded annually. If you don't see anything about monthly or yearly payments, and it mentions anything about compound, you're going to be using either the discrete compound formula or the continuous one. Now we know you only use the PERT formula if it says continuous. You only use the PERT formula if it says compounded continuously. It will say those words, either continuous compound or compound continuously. Here it doesn't say that, so we are going to be using the discrete one. Discrete compound interest. And so that formula, I'll write it over here to the left. Again, you'll have this formula available to you on the test. You'll be taking it on your own. It might be worth just writing all the formulas off to the side before you start the test, so you don't have to go flipping for them. And so now that we see the formula we have to use, we know the variables we need to solve for. Okay, so what will a $90,000 house cost 7 years from now? Well, if anything, time is 7, but that one's clear. The $90,000 house sounds like that's a principal value. But what will this cost 7 years from now? Of course, rates is 8%, which we can go ahead and convert. We do need to convert here because we're doing the formula ourselves. We're compounding annually, which tells us that M is 1. And then that leaves us with A. We don't know A. So we have to figure out A. So let's plug in everything we know. 0.08 divided by 1 times 1 times 7. So the good news is, since A is already by itself, we could just go ahead and throw everything in the calculator. So we're not multiplying 7 years by 12 months because we're not solving for capital N. In capital N in the TVM solver stuff, capital N is not the time, but we have to multiply the time by the number of compounding periods in a year. But just T by itself, that is just the time in years. And since it's already 7 years, that's already just given to us. We don't have to convert anything else. That's why it's just 7, because it's capital N versus T as variables. And so from here, let's quit out of this and just simply plug everything into the calculator and see what we get. 1,000, 1 plus 0.08 divided by 1, parentheses, caret symbol, open parentheses, 1 times 7, 7. Delete 7. There we go. Close and that.
So A always stands for the future value.
So A is, yeah, the future relative to some principal. There's one example we did where, what was it? It was the price, the rental spaces. I don't know if you remember that one. And they started off with a price 4 years ago, and they wanted us to determine the price now. So now was the future relative to 4 years ago. So as long as you distinguish that in your mind, then most of the time it's future though. But P doesn't mean present necessarily, it just means principal, which normally is present, but it's all relative. 2, 4, and they say round to the nearest cent. 4, 2. Oh, I did. Looks like I typed in a wrong value. Okay, thank you for pointing that out. Okay, I typed in something wrong, so you saw that. Yeah, I do that all the time, so thanks for remember that. I guess that's good you all saw me do that, because that same mistake is something a lot of students do. I've gotten a ton of emails about that. I forgot a 0. That happens all the time to students, and like I said, it happens to myself. And insert 0. That's the real value, which it makes sense. It only moves the decimal place over once because I lost a 0. So really, the true answer, 4. 0.18. That is the true answer. Oh yeah, I guess that would make sense. A 90,000 house would cost 15,000 in the future. Yeah, I guess that makes sense. Why would a house appreciate to a smaller value? It's a double entendre. Okay, cool. Thanks for the heads up. So that would be the answer we put into formula. 1542441. Does anyone have any questions about this before we look at another one? If not, you can afford monthly deposits of $270 to some account that pays 3.3% compounded monthly. And then how long until you have $5,200 to buy a boat? So first thing we do, we figure out which formula or method we use.
It says monthly deposit and it's monthly.
Well, in the context of Math 105, yes. So somebody was saying something else.
TVM solver?
We're going to use the TVM solver. So you might look at this and think, oh, it says compounded monthly. But that is immediately, that doesn't necessarily mean you're using compound interest here. So what overrides compounded monthly is monthly deposits of $270. That immediately overrides compound interest of any kind. As soon as you see monthly deposits, monthly payments, anything like, or annual deposits, annual payments, same idea. And so from here, we have the TVM solver. PV, PMT, FV, P over Y, and C over Y. Now, the reason why we did the TVM solver was because we saw that there's periodic deposits being made. That immediately tells us PMT, which I'm starting off with a negative. PMT is always negative by default. That's 270. That's how much we are paying each month, or depositing each month. And since we're doing this each month, it makes sense that these would both be 12. So many times we're paying a year because we're doing everything monthly. It's 12 months in a year. .3%, that one should be a little bit more obvious. And I suppose, what do we do with that 5,200? What's that?
Future value?
That's the future value. This is the future value. I think this problem tries to be a little tricky because it makes you think you bought a boat and now you owe 5,200. But instead it's saying you're putting into an account and then you're hoping for that account to become 5,200 and then you'll just go and buy off some boat. Which immediately means you're starting off with $0. This is some account you're paying into, which means you're solving for n. So let's go back to the solver. N is 0, I is 3.3, PV is 0, negative 270. 200, 10s and 12s. Alpha enter, And we see that n is, so they're saying round to the next higher month, if not exact. So they're saying round up no matter what. Just like the previous problem we did when we also found for n, when it said round to the highest or the next integer. Same thing here, that becomes 19. Round to the next higher month, so we're rounding to 19. So the final answer is 19. So the TVM solver problems should be pretty nice. There's really no algebra to it much at all, unless there's some down payment, which has a little bit of computation to it. But other than that, does anyone have any questions before we move on? Okay, so if you have $8,000 and that's invested at 5% interest compounded continuously, what's the amount after 3 years? Same thing as before. Simple interest, compound interest, TVM solver. One of those three does this fall under? This is compound interest. There's no mention of paying monthly or yearly, depositing monthly or yearly, nothing like that. So this has to be a compound interest problem. There are two compound interest formulas, and so we want to use the one that corresponds to compounded continuously. We have a formula just for compound continuously. So we're using the continuous compound formula, which is also known as the PERT formula. This is the PERT formula. We didn't really do too many examples with the PERT formula, but this is something that could easily be asked on the test. So the continuous compound formula, I wrote it on the left over here. And so we have 4 variables that we need to solve for. Again, E is not a variable. E is just some number that is so important and so widely used that really it's just a placeholder. It's some symbol for it. So the continuous compound formula, we need to plug in some of these values. Hopefully it's clear. The rate is 5%, which we can convert to a decimal. The time here is the number of years, which they generously gave us as 3. Isn't that 8,000 over here? To figure out where that goes. Start off with 8,000. What does that look like in 3 years? Sounds pretty straightforward to me. Why did I put 3,000? Let me try that again. 8,000. 8,000. There we go. And then we're looking for the future value. So let's plug in everything we know. A is unknown. P is known. E is just E. We don't plug in anything for E. R is 0.05 times 3. And good news here, no algebra. The unknown is on the left side all by itself, which means there's no algebra. We can just solve directly. So 8,000. I'll make sure I put all the zeros. And then E, we talked about this in class, it's second. And then there's the ln button. And on top of the ln button, that'll let you use E. 0.05 times 3. Round to the nearest cent. 4.67. Does anyone have any questions here? Okay. This problem may look familiar. We did this problem on one of the first days of class. This was the one regarding the lucrative radio commercial deal. 36 cents a day for each $500 borrowed, and we borrow $1,389 for 175 days. Well, the first question is, which section does this belong to? Does this sound like simple interest, compound interest, or TVM? Anyone remember this problem? Where it came from? It doesn't really say compound. It doesn't say compound anywheres. It doesn't say. This is going to be simple interest. This is a simple interest type problem. So, however, just to keep in mind, so you might recall when we talked about this problem, they're defining the interest their own way. So we'll start off with part A. The interest, so start off 36 cents a day, so 0.36, and there's 175 days. So this is not following a PRT formula or anything. They're just making up their own rules here. And then they do this for each $500 borrowed, and you're borrowing $1,389 in total. That's where you get $1,389 that you borrowed, and you divide that by 500. That's where this is coming from. Again, it's not following, this is not PRT. It's just their own rules for defining this. But the good news is you can just put all this in the calculator. You have a question?
So you don't convert the days?
What's that?
You don't convert the days?
You do not convert the days. Normally, so, and that's a good question. I've been asked that. You're not converting the 175 to years because you use that when you prep time for a formula. But since the radio station is not using a formula, we don't have to convert it in that way. And that's the main reason I've kind of rationalized in my mind why this one has so much singularity to it. And then 0.36 times 175 times 1389 divided by 500. And what we get, we're going to round to 2 decimal places, 175.01. But this is not the answer for part A. Tempting to put it because we just completed a sequence of steps and we got an answer. So naturally, we're inclined to put that answer in. They're not asking for what the fee was. They're asking for how much are you going to pay back in total. So the amount you pay back in total is going to be, well, how much did you borrow? And then how much was the fee? And that's what we're going to piece together here. So you borrowed $1,389. The radio station is charging you a fee of the 175 that we just found in the previous problem. And it's the sum that is going to tell us the amount you will pay back in total. $1564.0. That's going to answer how much you pay, how much you repay. So if anything, that answers part A. 1564.0. We're having some technical difficulties. That shouldn't be that. Great. Okay, I can live with that. All right, 1 second. Well, I guess I can do this. All right, 1 second. Let me try to fix this. Let's see if that fixes it. Well, this is fun. I guess you all hang tight.
Mr. Brad, I think you're muted. I can't hear you.
Can you hear me now?
Perfect.
All right, cool. Thanks. All right, so sorry about that. So we just found the part A. Did anyone write down the interest I just got? Was it like 750 or 01 or something?
175.01.
175.01. Okay, that was the interest that we found. And then altogether, we found that A was 1564.01. And so part B wants us to determine the annual interest rates. So really, we know what I is, we know what A is, and we're dealing with simple interest. So now we have formulas that we want to plug the stuff into. Really, so there's two formulas. There's that I equals PRT formula, and there's the A formula. We can use either one because we have a lot of variables at play here. Personally, I'd rather use the one that has less stuff going on. And now that we're using a formula, the I is the interest or the fee, which was 175.01. The principal value is how much you borrowed, which was the 1389. The time, this is when we convert the time to years. So it was 175, but now we divide that by 360 because now we're prepping time for a formula. So that's why we are doing that now. $175 divided by 360. That's 0.486. 1, 2, 3, 4, 5, 6, 7 ones. 1, 2, 3, 4, 5, 6, 7. So there's a point there. And so the rate is unknown. And so we can go ahead and plug everything in that we know. 389 times R times, well, really this stuff. Too much space here. So now we can, well, the bad news is we have to use algebra. The good news is that we can try to simplify some of the stuff before we proceed with the algebra. So we can multiply this with the value that should be right here. Which would give us 175.01 is equal to whatever that product comes out to be. So that would be 1389 times 0.486, 1111111. Or in other words, really I should have just done second and answer. $675.2083333 times R. And now the algebra is very simple because all we have to do is divide both sides, which would give us 175.01 in the numerator and then the 675.2083333 in the denominator. What this simplifies to, well, let's see what the calculator tells us. 175.01 divided by the previous answer. That's 0.259194075.9. And so they want us to round to 4 decimal places, but this is the rate, which means what the number we're seeing right now is the decimal form. We want to see the percent form. So we have to move the decimal place over twice to the right to determine this. So now that is 25.9194 as we round to now 4 decimal places after we move the decimal point. And this is the interest rate. $25.9194. That is the interest rate. Does anyone have any questions before we move on? If not, how does it work now? In any case, in order to accumulate enough money for a down payment on a house, a couple deposits $789 per month into an account, paying 3%, compounded monthly. Payments are made at the end of each period. How much money will be in the account after 7 years? Now I'm thinking. So the first question is, what type of problem is this?
TVM.
It's going to be a TVM. This is a TVM solver problem because we deposit $789 per month into some account. This is TVM solver. So there's an N, an I, a PV, a PMT, FV, P over Y, and C over Y. Let's see, what are some of these values? Well, negative 879, that's the reason why we chose the TVM solver. Tells us how much the monthly deposits will be. Paying 3%, okay, so 3 here. Compounded monthly. Monthly. And then what else is there? How much money will be in the account in 7 years? So 7 years, that's time, but that's not capital N. Capital N takes the time and then multiplies that by how often we pay in a year, which since it's monthly, it's 12 times. How much money will be in the account in 7 years? That tells us that we are looking for the future value and that you're starting off with no money in this account. So with all of this being said, we can go straight to the TVM solver. Thinking about my stats class. Okay, apps, enter. Let's go ahead and plug everything in. Times 12, 3, 0, negative 79. Placeholder 0 and some 12s. So FV comes out to be $73,646. But we're going to round up to the nearest dollar. So that would be 73,647 because it says round to the nearest dollar. So that's why we're rounding to the nearest dollar, not the nearest cent. As long as you can catch that slight nitpick by my math lab, then we can conclude with future value as 73,647. Does anyone have any questions about this one? Not, let's look at another problem. So there's an IRA account. It's a retirement account. We actually did a problem kind of based off of this. It has $20,000 in it. The owner decides not to add any more money to the account other than 3% interest compounded daily. So how much is going to be in the account 29 years from now? So first question, which formula do we use?
Discrete compounding.
Yeah, we're going to be using the discrete compound formula. It's not a TVM solver problem because, I mean, it explicitly states the owner decides not to add any more money into the account. So it explicitly states he is not putting money into the account periodically. Just got to let it sit in there and accrue interest over time. So from here, we know that this is discrete compounding. And the formula, and again, it's discrete compounding and not continuous compounding because it tells us we're compounding daily instead of continuously. 1 plus r over m raised to the m times t. And now we know what to solve for. A, P, R, M, and T. Then we just have to figure out these values one by one. Looks like 20,000 is what the account starts off with. The rate, I'll just go ahead and put 0.03. I'll just convert the rate to a decimal. The time seems to be 29 years. And we're compounding daily. So what does that tell us? We're going to be using 365 here. Again, it's this careful little detail right here. Notice they switched it up. It's kind of sneaky, but you know, it's my math lab, so. That tells us that we're compounding 365 times in a year for each day. And the future value is the unknown one. Well, the good news about this is that there's no algebra involved. 1 plus 0.03 divided by 365 raised to the 365 times 20. So we just plug everything into the calculator. 28,000. 1 plus 0.03 divided by 360. Try it again. 20,000 parentheses 1 plus 0.03 divided by 365 caret, more parentheses, 365 times 20. $47,736.51. $47,736.51. Does anyone have any questions about this problem? I figure I'll reserve the last few minutes. If you have any specific questions, you may ask me. Other than that, you are free to go. Do not forget the timeline of the Unit 1 assessment. Make sure you get all the assignments done that are upcoming, and have a good day.